In our last example, we want to take a look at the relationship between price and demand, construct some price-demand equations, and calculate some values related to those equations. The first thing we want to establish is just the idea that price and demand have an inverse relationship. We could explore that idea more, but it's probably fairly intuitive. The more you charge for an item, fewer people are going to buy it, versus something that's lower cost, more people are going to be able to or interested in purchasing that item. So as one of those variables increases, the other decreases. In example 6, we have a store that recently sold a particular item for $14.80. At that price, they sold an average of 41 items per day. When they raised the price to $17.35, sales dropped to an average of 19 items per day. Assume the relationship between price and demand is linear. In part A, we want to find a price-demand equation with price as the independent variable. In this problem, what we're given are two xy coordinate pairs, but in part A and B, what's going to be different is which variable is the independent variable. If we glance ahead to part B, demand will be the independent variable. So we just need to make sure we're paying attention to that language and then ordering our values correctly. If price is the independent variable, then our values for P will come first in each coordinate pair. So our first coordinate pair would be 14.8, comma 41. And our second coordinate pair would be 1735, comma 19. Once we've identified that coordinate pair, we can turn to Symbolab and we can ask it to find a line through those 2 points. And we get our result, which will round each of those values to 4 decimal places to give us the equation x is equal to negative 8.6275 times p plus 168.6863. Notice here that while we often set up linear equations as y equals mx plus b, c equals mx plus b, in this case, price P is the independent variable, so it needs to be on the side of the equation with the numbers being multiplied, added, subtracted. And then our value for demand, x, is the dependent variable. That's the variable that's isolated by itself. For part B, we're going to complete the same process, but we're just going to flip the order of those values in our xy coordinate pairs. So now demand is the independent variable, which means that production, or that number of items sold, 41, will come first, comma 14.8, and 19, comma 17.35. We could flip over to Symbolab and again ask it to create the straight line, or to create the line through those 2 points. Now what we would come up with would be an equation P is equal to negative 0.1159x plus 19.5523. Again, we're using x and p, since those are the two variables here, items sold, or demand, and price. In this case, demand is the independent variable and price is the dependent variable. Another thing to notice is that our slopes are negative in both cases. That makes sense because price and demand have an inverse relationship. So as one variable increases, the other should decrease. So we should always end up with a negative slope for these types of situations. And then in part C and D, we want to evaluate these formulas for specific values. In part C, we want to use the appropriate equation to find the daily demand if the prices change to $18.60. Here we just need to think about which equation makes more sense to use. In this case, we'll take our equation from part A, because that's set up to let us plug in a value for P, $18.60, and generate that corresponding X value. What we'll do then is evaluate that expression that we have in part A, negative 8.6275, P plus 168.6863 for P equal to 18.6. And we get a value of 8.2148. Or the way we would want to report that answer is to say that X is approximately 8, because 8 corresponds to demand, the number of items sold. We can't sell half of an item, a portion of an item, so we have to round that to the nearest whole number. In part D, we'll want to use our equation from part B, because that one is set up to let us plug in a value for X, the number of items sold, which in this case would be 62. So we could use a similar process. We would plug in 62 for X and generate a result of P is equal to 12.3665. But P represents the price we're charging for an item. So in this case, P would be $12.37. And what we're saying is, if we charge $12.37 for this item, then we should be able to sell 62 items per day.